Hello, everyone. Welcome back to the second track of this day. As world is shifting towards the data and understanding about how the data strategy will be helpful in the digital transformation, we have the sorry, we have the second track. It's all about the data and its strategy, how you can leverage the data for the digital transformation. And for that, we have the Amarjit with us. Hey, Amarjit.
Hi, how are you? It's great to be here.
Yeah, welcome to the stage. And Amarjit is going to talk about the better APIs through better and more timely data. And yeah, we are really excited and looking forward to this talk.
Thank you. Thank you all. Can you see the
Thank
slides
you.
okay? Okay, so thank you all. What I really want to talk about is as introduced is how we can build better, smarter APIs and how they often need to have a smarter and a faster data platform that kind of underpins them. So a bit about myself. So my name is Amarjit Basra. I work out of the UK as a data architect for DataStax, and I work closely with enterprises, helping them across their digital transformation journeys. And if we look, at the evolution of APIs, so APIs remain, the fundamental building blocks that many enterprises and architects still use. They're the mechanism that allows systems and applications to kind of almost communicate and interact with each other. And they're there designed basically to allow you to share vital information, and that might be for a number of reasons. It could be compliance reasons, as we have for things like open banking, and that's to kind of facilitate maybe better and much more seamless customer experience. APIs are also there where we design them to allow much more efficient use of our internal business processes to allow kind of that flow and sharing of information through. And many banks and financial institutes kind of have traditionally relied, and many still do, in holding their data in their monolithic type of systems. And that might be um, your mainframes. It could be relational database systems. And what happens is, that's led then to the creation of things like API facades to open up that underlying data. And we start to see things like the adoption of things like EAI, enterprise service buses, event-driven architecture, and that often leads to things like having proprietary interfaces, maybe combining and looking at different message formats, and all around allowing applications to be able to communicate, and talk to each other. And in the early days, we started to see things like remote procedure calls, in that one of the first earliest forms of APIs, and they were, very much designed to execute blocks of code, on a different server. And then we started to see things like the adoption of SOAP APIs, and this kind of introduced the concept of, being able to send things like XML payloads, and maybe better security as well. And more, we started to see more recently things like the standardization of things like REST to introduce concepts of statelessness and access things like resource entities. And then the rise goes further than that. So standards, we start to see things like GraphQL, gRPC, which is then more focused, allowing much more kind of efficient querying and accessing of information. And the key is that this kind of evolution of APIs that we're seeing in businesses is not something that's happening standalone. It's part of, the digital transformation journeys that many enterprises and businesses are embarking on. And it kind of goes hand in glove, with designing things like microservices, looking at things like cloud adoption, and things like building agile CDCI pipeline. So it's all part of this kind of movement to get, work better and more efficiently. And, data remains and probably still is probably the most important asset that many businesses, and especially banks and financial institutes will hold. You know, APIs provide a really good mechanism to allow you to access and share that data, and help drive that business value. Exposing your data through APIs, we do that to allow things like the acceleration of innovation. We do that so that we can start to do things that have actionable insights, so we can start to make smarter decisions. And APIs also kind of help bridge a gap between our legacy systems and our new technologies, that our new modernization, and the ability to be able to kind of access and live in that very hybrid mode, between those two states that we have. And so if we look at a very simple example that many people are familiar with, REST APIs, or representational state transfers, are commonly used, and most people are familiar with these when we're calling a web service. And they're designed really for applications to make requests, receive responses using things like HTTP verbs, things like your get, your put, your post, and your delete operations. But these verbs map directly on to those kind of CRUD operations, your creates, your retrieves, your updates, and your delete operations. And these are normally the things that you would associate with a database. Now, APIs are not kind of databases, but they are protocols that help govern, how data can be shared between systems. So there's a real close kind of collaboration and understanding between the two. And open banking, is seen very much, as a very collaborative model. It's where, core, banking data, very, private data, of a customer is shared, in a consented manner between unaffiliated external parties. And it's there and it's shared to, allow, you to have, more competition. It's to enhance the marketplace offerings and the capabilities. And these are all done through APIs. So if we look at an open banking endpoint like the one that's on the screen here, this allows an AISP, or an account information service provider, to kind of return account and transactional information, from systems of records that are sitting in the bank's back end. And it's really the depth, the range, and the quality of data that we make available. That's what's going to drive collaboration and revenue generation. So while open banking is there to facilitate kind of new market offerings, it often requires your back-end services. It requires your back-end APIs. It requires the data platforms that hold in that data, and they need to be just as robust. They need to be just as secure, and they need to be just as scalable to kind of, to meet the needs. And, digital transformation and, modernization projects that many enterprises and businesses go on, they do that because there's a need, or maybe an enforcement of a change, that's put upon them. And these changes can be, either regulatory driven, so this is things like PSD2, maybe Consumer Data Acts, and this is the adoption, of open API frameworks that allow products, payments, and services to be shared. Now, that change can also be competition or market driven, maybe where there isn't a compulsory open banking requirement, but the market is choosing, to share data, and we end up with things like fragmented frameworks. But the key is still around opening up and sharing data. And quite often, the digital transformation projects, the kind of the API projects, often take a top-down approach. The key focus often is around, the front end, maybe the mobile, the channel, specific applications, those that are aligned to the line of business. And they're often redesigned to handle very high interactions, and we do that by making those applications into microservices. Those microservices are often offer things like APIs for consumptions, and they will call other microservices or API layers, and then we start to see the creation of things like service meshes. And often, when we're designing microservices, they're designed to be cloud native. They're designed to kind of run in containers, and scale on demand. And from an infrastructure perspective, a lot of these, the infrastructure as well, we start to see the movement of that from physical to VM, hybrid and to cloud, because we want services to be able to run anywhere. We want, them to also benefit from things like cloud economics as well. But it's often kind of the data, that we want to serve up. That's what we normally call it. That's why it's saying it's the last mile. It's the last bit of that transformation that needs to be looked at as well. Because quite often that data remains locked into many of the banks and financial systems, legacy systems. And so therefore, you need to have a data strategy, that maps, the application requirements. It needs to be able to offer that linear scalability, and that high availability. And often, what we see is the adoption, of an open ecosystem, that can really help accelerate and assist enterprises in their journey. So things like open source. The reason is open source projects, often drive better adoption. They provide better business agility. They stop you from, they give you the freedom from having things like vendor lock-in. Open source, due to its nature, encourages things like better innovation, standardization, and collaboration between technologists. And if we look at things like Kubernetes, it's both, an open source project, and it's also a de facto standard for things like container organization, that allows you to deploy applications, allow you to kind of scale and deploy them anywhere. And even the adoption of open source standards for protocols, it's there to allow interoperability, and ease of communication between systems, so it happens much, much more easily. And all the software layers, need to have, be fast, agile, and have that same kind of standard. Your data platform, needs to mirror the application layer in terms of scale and elasticity, and that then, helps in terms of accelerating the adoption of APIs and allow data to be served regardless of, the consumption of those APIs. So, it's no longer a bottleneck. And if we look at the concept, of API layers in terms of a data strategy, maybe we can think of these as two distinct abstracted layers. You have the domain specific layer, and you have a very data centric layer. Data centric APIs, these are seen as kind of wrappers that abstract away, complexities of maybe, the database. They allow applications to kind of query and serve back data in a very efficient and very easy manner. These APIs, they provide low-level operations, things like the creation of tables, the working with data entries, data, searching across multiple data sets. The APIs are designed to allow interoperable, mechanism of access points into managing those data services. And quite often what we see is that these APIs, the data-centric APIs, are often extended to include things like DevOps APIs as well. And this then allows you to have complete database lifecycle management, user control, access control management into your data. And then, the data APIs are intended to be called and abstracted away by other services and other API layers. And those are ones that are very aligned and specific, maybe to a channel, a product, a line of business. They're the domain-centric layer and domain-centric APIs. And often these might be externally, exposed. And what they'll do is they'll interact with the lower layers. The domain applications, will tend to do multiple calls to the lower layers, and they will do maybe the filtering, the aggregation, and maybe the reformatting and re-rendering of that data, so that's it's as appropriate to the specific channel. And the ideas of having this separation and abstraction of the layers means that you now have a very loosely coupled design, and you can and have the ability to be able to swap out components and services much more easily through. And another important factor that we need to look at is when we're looking at APIs is really that developer experience. And this is from two angles. It's those that are building the APIs as well as those that are consuming the APIs in applications. The basic concept of an API is there to share data or information, and often, as a developer, there's lots of different data models that we have to deal with, and these include, we have to work with things like very structured tabular data, flexible schemaless JSON data, right way through to kind of graphical representations. And as an API developer, we don't want to care how that data is physically stored, by that data fabric, but we want to have the freedom to be able to access and serve all those different types that are related to the use case without having to do huge amounts of transformations and decoding. We also want to be able to have the choice of what development language that we should be writing in, that's best fitted for the environment. We shouldn't have the data or the underlying data platform that's dictating that. As developers, want the freedom of choice here. And as developers building these API apps, we really care about the availability of our service. We want it to be highly performant, highly scalable to the demands, and therefore the whole complete stack needs to be mirrored and aligned to that. And really the choice of APIs that you have now, this here is just a sample, but it's a complete spectrum that you have. And as a developer, what you use, very much depends on the specific data types of the use case. And then there's obviously the performance trade-offs that you get between all the different specifications. The fastest and probably the most performant access has and always probably will be native access into your database. But architecturally, that's going to be probably the least flexible design, because it means that you're really tightly coupling, your application, and having to understand native calls, the real implementation of different specific data types that you're going to have to kind of work with. And REST, is now, almost a de facto standard, and it's very commonly used in API format, and it provides a real practical way of using HTTP verbs to be able to access specific data resources. And while, REST is a lightweight API, it may not be suited to all your scenarios because it can suffer from things like overfetching, where you're retrieving way too much information from fixed endpoints that you don't need to use, or underfetching, where you don't have enough information, then you're constantly kind of making calls, and in both of those scenarios, there's performance issues. There's maybe more bandwidth that you need to use, more data you got than you need to use. you know and then we're starting to see things like GraphQL, gaining real popularity. Again, it's an open source data querying language. It allows you to query, the data to tailor your request to exactly what you need. It allows multiple, data objects to be accessed, allow you to specify specific fields that you want to query. And it helps avoid the overfetching and the underfetching that I spoke about earlier. Now, we also start to see things like gRPC, and that's a very highly performant, open source remote procedure call framework that was created by Google. And that's, sometimes suited for very lightweight, real-time streaming of messages, maybe things like IoT use cases. And of course, then there's the schemaless document APIs. They're very flexible to work with. They're based around JSON documents. You have the ability to be able to create a schema on the fly. You have powerful search capabilities that allow you to search for specific documents or collection of documents. You can fetch, the full JSON documents or subparts of that document as well. So there really is a real range that needs to be considered, and sometimes it's not necessarily picking one; it's picking the best ones that meet your needs. And then there's obviously the data model. That's another factor that needs to be considered. Data is often stored at the underlying persistence layer, that data fabric layer specific to the business need. Structured data, that we normally associate with relational systems. The enforcement, takes place at the database layer. Fields are very strongly typed. They're linked directly to a table schema, and it means that you can only, put in that type of data or query that specific types of fields. And REST APIs are very well suited at making those CRUD type of operations and accessing those entries. Whereas your document APIs, they're based more on the loose structured JSON format, but the responsibility of ensuring that standardization and consistency is now at the app layer. It's with the app developers. It's that responsibility that goes there. And things like graph models and queries, they're a lot more focused on relationships, and connectivity of data structures and objects, and maybe more suited to, where you're looking at advanced insights or complex workloads, but you need to know, the tables and the fields that you need to access for that. And, if we look at a very simple walkthrough, of maybe how an application within the context of, say, a fast data layer, typically works. And if we look at it from an architectural diagram, what we see on the top left here, is your legacy applications and your legacy systems. And quite often they're pumping the data, into a system of record. There's data that's kind of flowing through. And then we also have external data, and what's happening is that enterprises now are kind of moving away from batch processing and more towards real-time streaming. So often, we'll see things like your change data capture processes being introduced, that makes the necessary enrichment and a transformation of data. But it's really this key bit here. What we see is that data is held in what we call a system of engagement. It's a data platform that holds your summarized, maybe your consolidated data from all those different data sources that you have within a bank or financial service institute. And it's from here, that we're accessing and retrieving the data for our customers and clients. The system of engagement, this is what is powering all your digital experiences. You know, we as we develop modern applications, we have a line of business, we have a front end applications that are often written as microservices that are accessing that data, and we're building open APIs through, but they're all kind of getting that data through from the system of APIs. And when we look at what the capabilities of a real-time data layer needs to be, the first two are relatively easy, high throughput in terms of writes, low latency reads. They're important in being able to handle your real-time requirements of being able to store data, and being able to retrieve data without putting burden on your legacy systems. um, that third item, improve agility and productivity. That's another way of thinking about it. If the fast data lake, if the system of engagement can provide and accelerate developer agility and productivity by providing some of those APIs directly, if we can provide you know those APIs, it means then that as your modern apps and your APIs, you're there more focused on your business requirements, and you're simply consuming the APIs. You're just consuming the data that's available for you. That's where your focus is on. And as I move to my final slide, um, now what I want to touch on is really maybe a concrete example of this, of the API, of an API gateway, and that's Stargate. So Stargate, is an open source project. It's built upon open source Cassandra. The stack itself is completely cloud native. It supports the range of data models that I spoke about earlier. But what it does also is it provides those APIs. It provides the ability to have agility, developer freedom to be able to access all your data, to be able to do all those DevOps APIs. It means then, as either architects or as developers, the focus is purely on consumption, because a lot of that, you know, work around how I access that data is abstracted away and is simplified for you.
Okay, Amarjit, thank you very much for sharing about the different kind of data strategies for the building a better APIs. Folk, if you have any question, please reach out to Amarjit on his LinkedIn. Okay, Amarjit, thank you. Thank you very much.